Next is question number 66, which says that if the set of exhaustive values of x satisfying 3 raised to the power 4x plus 9 raised to the power mod of x minus 1 is less than equal to 10 is this one. Then we have to find the value of m plus n, right? So we have to find the values of x which are satisfying this inequation. So we have been given 3 raised to the power 4x, that can be written as 9 raised to the power 2x plus 9 raised to the power mod x minus 1 is less than equal to 10. So we can open the mode. Here we will have two cases. Case 1 where x minus 1 is greater than 0 and case 2 where x minus 1 is less than equal to 0. Now here let's assume that 9 raised to the power x is equal to t. Now if x is greater than equal to 1, it will mean that t will be greater than 9, right? So we will get the inequation as t square plus 9 raised to the power x minus 1. So we will get t upon 9 minus 10 is less than equal to 0. Now here as we have that t is greater than equal to 9, so this value can never be non-positive. So from here we will get x belongs to 5. Now here we have x minus 1 is less than equal to 0, which means that x is less than equal to 1, which means that 9 raised to the power x, that is t, is less than equal to 9. So here we will get t square plus 9 raised to the power 1 minus x, that is 9 divided by t minus 10 is less than equal to 0, that is t cube minus 10t plus 9 is less than equal to 0 as t is also greater than 0. So we will write it as t minus 1 multiplied with t square plus t minus 9 is less than equal to 0. So finding its roots, t will be equal to minus 1 plus minus under root of 1 plus 36, that is root 37 upon 2. So from where we curve, let's see, we have 3 roots here, minus 1 minus root 37 by 2 and minus 1 plus root 37 by 2. So it is less than equal to 0, which means that these two are the required portions, but t is less than 9, but t is also greater than 0. So only this option is here, that is 9 raised to the power x will belong from 1 up till minus 1 plus root 37 upon 2. Hence from here we will get x belongs from taking log to the base 9 on both sides. We will get 0 up till log to the base 9 minus 1 plus root 37 upon 2, which means that value of n is equal to 37 and value of m is equal to 0. So the value of m plus n will be equal to 37. So option number 4 is the correct choice. Next is question number 67, which says that if f goes from 0 to infinity up till 0 to infinity and fx is equal to x upon 1 plus x, then f is. Now here fx can be written equal to, let us add and subtract 1 here. So we will get it equal to 1 minus 1 upon 1 plus x, and let us assume fx equal to y. So this is equal to y minus 1 into 1 plus x equal to minus 1. So it will be a rectangular hyperbola. Let's plot its curve. Let's say this is the line x equal to minus 1 and this is the line y equal to 1. As it can be seen that the curve is passing through the point origin, so the curve will be like this, right? So for x going from 0 to infinity, we can see that y is going from 0 to 1. So it is clear that range is not equal to codomain, which means that the function is into. Also from the curve it can be seen that the function is 1 1. So the function is 1 1 and into, which means that correct answer is option number 1. Next is question number 68, which says that the range of the function y equal to fx satisfying the equation 2 raised to the power sin x plus 2 raised to the power y is equal to 1. Now we know the range of sin x, that is sin x goes from -1 to 1. So we can say that 2 raised to the power sin x will go from 1 by 2 up till 2. Now if we talk about -2 raised to the power sin x, so we can say that it will go from -2 up till -half. Also adding 1, we will get 1 minus 2 raised to the power sin x will go from -1 up till half, which means that 2 raised to the power y goes from -1 to half. Now we know that 2 raised to the power y is always greater than 0, which means that 0 is less than 2 raised to the power y is less than equal to half. Now we have to find the range of y. So we will take log to the base 2. So we will get minus infinity is less than y is less than equal to log to the base 2 half. That will be equal to log to the base 2, 2 raised to the power -1, that is equal to -1. So we can say that y is going from minus infinity up till -1. So correct answer from the options is option number 3. Next, let's talk about question number 69, which says that number of values of x satisfying the equation greatest integer of ln of 1 plus x is equal to ln of 1 plus x plus greatest integer of 1 plus x whole square minus 3. A very nice question. So let's discuss it. Now here, first thing which we had to analyze is that the value on the left hand side is an integer, and here this is also an integral value and this is also an integral value, which means that ln of 1 plus x should also take an integral value. Only then the equation can be satisfied. Now we have ln of 1 plus x belongs to integer, right? Now if ln of 1 plus x is an integer, then there is no point of writing GIF on it. So GIF on the left hand side can be removed. So we will get ln of 1 plus x is equal to ln of 1 plus x plus greatest integer of 1 plus x whole square minus 3. Now these two will get simply cancelled. So we will be left with greatest integer of 1 plus x whole square is equal to 3, which means that 1 plus x whole square will go from 3 up to 4, right? Which means that mod of 1 plus x will go from under root 3 up to 2. Now we know that ln of 1 plus x belongs to integer. So if we take ln here, we will get ln of mod 1 plus x will go from ln of root 3 up till ln of 2. Now we know that ln of 1 is 0 and ln of e is equal to 1, and root 3 and 2 both belong between these two values, which means that there is no integral value of ln of 1 plus x that is possible. So number of values of x which are satisfying this equation is 0. So answer is option number 4. Next is question number 70, which says that the range of the function fx equal to greatest integer of sine inverse x plus greatest integer of sine x is, right? So let's break the function. Firstly, let's talk about sine x greatest integer. Now this will be equal to 0 for x going from 0 to 1. Now here, firstly the domain can be checked as we have sine inverse x function here. So domain of the function is x belonging from -1 to 1, right? Now greatest integer of sine x will be equal to -1 when x will belong from -1 up till 0. Very simple. Now if we talk about sine inverse x, now this will be equal to 0 when x belongs from 0 to sine 1, and it will be equal to 1 when x will belong from sine 1 up till 1. Also, it will be equal to minus 1 when x goes from minus sine 1 up to 0, and it will be equal to minus 2 when x belongs from minus 1 to minus sine 1. Now, we have to add these two functions and we have to find the range of fx. So, fx will be equal to, now, when x is going from minus 1 to minus sine 1, then the value will be minus 2 minus 1, that is minus 3. And when x is going from minus sine 1 up till 0, then the value will be minus 1 minus 1, that is minus 2. And when x goes from 0 up till sine 1, then the value will be 0. And when x goes from sine 1 up till 1, then the value will be 1 plus 0, that is 1. So we can say that the range of the function is minus 3, minus 2, 0 and 1. So answer will be option number 3.